Hello, welcome to my video. This is Bro, and today we are going to discuss on the total power system, that is from the thermal power plant, how the electricity is passed to the step up transformer, then it goes to the high tension transmission line, then after that it goes to the step down transformer for the transmission to the local for the all the houses purpose. So in the thermal power plant, it can be a nuclear power plant, hydroelectric power plant, solar power plant, wind power plant. There are many types of power plant for generation of electricity. So we are going to start one by one. So we are going to start a thermal power plant and its functions and various other things, and also what are the equipments of the thermal power plant. There are boiler, heat exchanger, air preheater, then supercritical boilers. Even in supercritical thermal power plant, we have already discussed about the transformer, step up step down transformer, and the transmission line. So we are going to start one by one. So now I'm going to start with one easy question regarding the thermal power plant. So I'm going to start with the first question, that is oil fired reheating furnace. Oil fired reheating furnace has an operating temperature of around 1200 degrees Celsius. The average oil consumption, the average fuel oil consumption is 420 liter per hour. The flue gas temperature after air preheating, the flue gas temperature after air preheater is 320 degrees Celsius. So what we have to find out? Find out the percentage sensible heat loss in exhaust gas. So what are the given values? That is the specific gravity of oil is equal to 0.92. Calorific value of oil is equal to 9300 kilocalorie per kg. Average oxygen O2 percentage in flue gas is 13%. Ambient temperature, what is the value of ambient temperature? Is 40 degrees Celsius. And other is specific heat of flue gas. Specific heat of flue gas is 0.25 kilocalorie per kg degree Celsius. So now we have to find out the input energy. Input energy, what is the input and what is the output, and then we can find out the sensible percentage heat loss in the flue gas. So one by one we'll try to find out here. So first is the input energy. What is the input energy? Input energy is equal to we have already oil consumption is 420 liter per second. So this is 420 into 0.92 into 9300, that is kilocalorie, calorific value of oil. So if we can calculate or multiply all those values, so we'll get the value as 3593520. 3593520 kilocalorie per hour. So this is the input energy. So we can find out what is the flue gas percentage excess air. Excess air, we know the value of excess air, that is O2 divided by 21 minus O2. So O2 percentage, what is the value of given O2 percentage? That is 13. Here is 13 divided by 21 minus 13, that is 13 divided by 8. So if we can divide this value, that will be given as 162%. So now what we have to find out the value, that is the theoretical air required. Theoretical air, that is we have 1 plus excess air divided by 100, then that is being multiplied by percentage of percentage, that is a 14% percentage of air. So that is 14. So here we can know 1 plus 1.62 into 14. If we can multiply this one, so it is 2.62 into 14. So it is coming the value, that is 32.68 kg. The kg per kg degree Celsius, kg per kg degree C. So what is the value of M? M is 1 plus theoretical air and that is coming as 1 plus 32.68, that is 33.68. So this is the value of M. So now I'll it is the first part. So first part erasing, input energy is Q. Q is nothing but mCp into del T. Mass is already out here, that is 33.68. What is the Cp? Calorific value. Calorific value is already given, that is 0.25. 0.25. Del T is nothing but 320 minus 40. So if we can calculate the whole value, so we can get the value as 168 kilocalorie per hour. So this is the output. So we can easily find out the meaning of efficiency. Efficiency is nothing but output by input. So we know what is the output. Output we have found out, that is 1019168, and input we have already found out, that is 3593520 into 100. So if we can calculate this, that will be the value 28.36%. So I hope you have got the values and how to calculate the efficiencies and others in the thermal power plant. So I end my video here. We'll continue my next class from after that one. Thank you very much.